Inferential statistics involves collecting sample data and using probability based on some things we know about the distributions to make a prediction or an inference about a population. Okay? We're making that decision based on probability, and we try to make sure we have high probabilities that we're making the correct decision, but unless we use the entire population, it's not 100%. Okay? We could be making the wrong decision. Okay? When you reject a null hypothesis, you're doing it because you have really strong evidence. You're saying what happened in my sample would only happen a very small percentage of the time if the hypothesis were true. Well, it still would happen a very small percent of the time, and if you happen to get unlucky and your sample was that small percentage of the time, you've made a type 1 error. Okay? So that's what a type 1 error is. It's when you reject the null hypothesis correctly statistically because you got a small p-value based on your sample, but in reality it was just due to the random sampling and the null hypothesis is true. You're making the wrong decision about the population, not because you made a mathematical error. This is not a mathematical error. You're making the wrong decision because you don't know what's true for the population and you're using your sample and you just got unlucky and your random sample caused you to make the wrong decision here. Okay? We can control this. It says on the next slide, the probability of a type 1 error is alpha. Okay? Your significance level. If you're going to only reject when your p-value is less than 5%, then 5% of the time you could make that type 1 error. Okay? Your significance level is exactly the probability you make a type 1 error. So we can make that as low as we want. And typically we go with about 5% or maybe 1% if the stakes are higher. You can also make an error the opposite way. If you fail to reject the null hypothesis because you got a large p-value and it just wasn't strong enough evidence to be confident because you don't want to make that type 1 error, but you failed to reject when really it was false. The null hypothesis was not true, but we didn't find strong enough evidence to reject it. That's called a type 1 error. Okay? Now, when you reject the null hypothesis and it's false, you made the correct decision based on the population. When you fail to reject and it's true, you made the correct decision. So if you look at the little table there, there's 4 possibilities. Either you're correct or you're making a type 1 or a type 2 error. But think about it that way. When you reject the null hypothesis and you're wrong, it's a type 1 error. When you fail to reject the null hypothesis and you're wrong, it's a type 2 error. Let's look at a contextual example of that. And it can be bad to make this type of error in either case, and it depends on the situation as to which one might be worse. But let's look at this example. So hopefully in class somewhere along the way, we've looked at this example. I'm referring to an example. It's one of our practice problems. Hypokalemia is when your potassium level is too low. And in this particular problem I'm thinking about, the potassium level of 3.5, if you're below that, you're considered hypokalemic, and a doctor took random samples of the blood and tested that and made a decision. Okay? The doctor might be making a wrong decision. This kind of hits you hard when you start to realize this in life, right? When you go to the doctor, they're going to make decisions based on the symptoms you're showing, but they're never 100% certain about a lot of things, right? That's just the way that life works, unfortunately. So you might be getting the wrong result on your tests. So in this particular case, think about a type 1 error. So if it was a type 1 error, that would be when you get a small p-value and you reject the null hypothesis. So let's look at what would that mean here. If we rejected the null hypothesis, we would be concluding that her potassium level is less than 3.5 or she has this hypokalemia. And then you would probably prescribe some medicine, which might just be potassium, more potassium in this case. But anyway, think about it as any disease. You reject the null hypothesis, you conclude this person has the disease, and you prescribe them a treatment. It's a type 1 error if you're wrong. They don't have the disease, but you found that they did because you rejected the null hypothesis. That's a type 1 error in this context. A type 2 error would be to fail to reject the null hypothesis, which means in this setting that they did not conclude that she had the low potassium level. So you would fail to conclude that the person has a disease, and you probably wouldn't prescribe the treatment. So you see, either of these could potentially be bad, right? Either you're giving somebody medical treatment they don't need and telling them they have a disease that they don't, or the opposite, which might be worse, you don't find that they do have a disease that they need treatment for. So you want to be able to avoid type 1 and type 2 errors, and that's why we make the significance level relatively small.